Hello everyone. In this video I am going to demonstrate how to use PT100 RTD to measure temperature using a Wheatstone bridge. As you can see, this is my setup. This is the Wheatstone bridge you can see, and this is the RTD. This is the RTD. This is the RTD. So this is a 2-wire RTD. I am using a 2-wire RTD. I am not using 3-wire or 4-wire. This is just a 2-wire RTD for initial test. So as you can see here, this is the Wheatstone bridge, and you can see here these are the 400 ohms resistors. So these are the other 3 arms of the Wheatstone bridge, and the PT100 is another arm of the same Wheatstone bridge. As you can see, it is connected like this to the another arm of the Wheatstone bridge. The Wheatstone bridge is powered with 3.3 volts DC power supply. So as you can see here, the Wheatstone bridge, I am going to show you the layout of the Wheatstone bridge. So this is how the Wheatstone bridge should be. So as you can see here, there are 3 resistors. So these 3 resistors are fixed resistors, and this resistor is the PT100. So whenever I am going to heat the PT100, there will be change in resistance and there will be a voltage change across the bridge. The bridge will become unbalanced and I am going to detect the unbalance. So the unbalance will be detected on the multimeter. So as you can see here, this is the basic formula of the Wheatstone bridge. There is one more formula of the output voltage whenever there is unbalance. So now I am going to simulate an unbalance. So presently, whenever I am not heating the sensor, there is no heat on the sensor, the multimeter is showing 0.310 volts DC. You can see this is the multimeter reading whenever there is no heat on the sensor. Presently I am not keeping the sensor in ice, that's why the reading is 0.325 millivolts. Whenever the sensor is on the ice, it will read 100 ohms and there is a chance for bridge balance. That time the millivolts will be much less. So since the millivolt is not now much less, it is say something 118 ohms. So that's why I am reading here 309 volts DC. So now I am going to heat up the sensor. So this is the sensor and I am going to heat up this sensor. So as you can see here, I am heating up the sensor. You can see I am heating the sensor. You can see there is a heat on the sensor. And you can see the reading on the multimeter is increasing. You can see the reading on the multimeter is increasing. When I am heating the sensor, the reading on the multimeter is increasing. So this is how the RTD is making the bridge unbalanced, and we are reading the millivolts. As you can see, this bridge, the R4 is getting unbalanced, and we are reading this value 0.627. Now I have stopped hitting the sensor. You can see the voltage difference is reducing. The voltage is coming down. The differential voltage is coming down. You can see the voltage is coming down. So this is the Wheatstone bridge. You can see the voltage is now coming down. I am going to heat the sensor again. You can see the voltage is again increasing. The bridge is getting unbalanced because the PT100 is getting heated up. So this is how the Wheatstone bridge is used to measure RTD temperature resistance. Thanks a lot. Thanks for watching.